Very pleasant morning to all join here. Now I am going to present the topic statistical quality control. The most important word in statistical quality control is quality. The quality of your product is satisfactory when it is able to satisfy the stated and implied needs of the customer. The customer or consumer is a person or organization that use the product. Quality doesn't mean merely the goodness or fitness of a finished product. It is a relative term and is used generally with reference to the end use of the product. Since the product is manufactured for the use of a customer, the requirement of the consumer dictates the quality of the product. Quality is to be planned, achieved, controlled, and improved continuously. Distinct means of quality. Quality of design, quality of conformance. Quality of design refers to the difference in the specification for products which have the same use. Quality of design thus refers to the method of construction, processing, material used, style factors, safety factors, etc. Quality of conformance refers to the ability of the productions process to maintain the specified quality of design in the long term. In other words, quality of conformance may be considered as the measure of truthfulness which will the product conform to the design specifications. Quality control is a name given to the collection of techniques and devices used to manage, monitor, and control all the steps in the production of product of desired quality. It is a powerful statistical technique for effective diagnosis of lack of quality or lack of conformity to settle standards in any of the materials, process, machines, or in products. Aims or objectives of statistical quality control to improve the company's income by manufacturing products more acceptable to the consumer, providing long life, greater usefulness, maintainability, etc. To reduce company's cost through reductions of the losses due to defects, non-conformities, to achieve lower scrap, rework, customer returns, etc. To produce optimum quality at minimum cost. To ensure satisfaction of consumer with products to build goodwill, confident reputations of manufacturers. Judging comfortability of the products to the stated standard and taking suitable actions where there are non-conformities, developing quality consequence in the organization, providing a running commentary on the performance of machines and operations in the production process. Characteristics. When quality is considered, it is specified by one or more characteristics and can be studied independently or jointly. The quality may be technological, strength, hardness, diameter, life length, etc. Psychological factors, taste, beautiful, etc. Ethical factors, honesty, integrity, etc. Contractual guarantees, safety, provisionals, etc. These factors are under quality characteristics. The quality characteristics observed in industry may be generally classified into any of the following categories: directly measurable variables, non measurable attributes. Variables: thickness, life length, temperature, tensile strength, etc., producing continuous data. Non measurable, these are under attributes: cracks, breakage, assembly defects, air bubbles, etc., producing discrete data. Causes of variations. Once the design of quality has been specified, well, the production process will be adjusted to manufacture the product according to the specifications. At this stage, the problem of conformance, producing items that conforms to the design specification starts. The problem arises from the fact that every manufacturing process exhibits variability. Variations in the quality of manufactured products in the repetitive process in industry repetitive process in industry is inherent and unavoidable. Variations may be due to tool wear, machine variations, vibrations, loose bearings, faulty fixtures, humidity, poor ventilation, poor quality of raw materials, carelessness of labor. These are some variations may be due to the causes of variations, maintenance factors and measuring errors, voltage fluctuations, weather conditions are under cause of variations. Variations affecting the productions process are broadly classified as being due to two causes: chance cause and assignable cause. Chance cause, common cause, random causes. The assignable cause, non-random causes or special causes. Chance causes, minor causes that behaves in random manner. The variations due to these causes is beyond the control of human hand, cannot be prevented or eliminated under any circumstances, many in number, each contribute a little to the variations, are continuously active in the process and are built in as a part of the process. The natural or inherited variability of the process is the cumulative effect of these uncontrollable chance cause. The range of such variations, called allowable variations, is known as natural tolerance of the production process. Assignable causes, generally few in numbers, each has a significant effect in the variation of the output of the process, can be deducted, can be eliminated from the process. Such variations are termed as preventable variations. Natural or inherited or allowable variations plus unnatural or external or preventable variations will be total variations in the production process. The main purpose of statistical quality control is to derive statistical techniques which would help us in separating the assignable cause of variations from the chance cause of variations, thus enabling to take actions whenever assignable causes are present in the production process. The elimination of assignable causes is described as bringing a process under control. The production process is said to be under statistical control or simply under control or within control if it is governed by chance cause only. If the absence of assignable causes of variations, which are the main purpose of statistical quality control, to eliminations of assignable causes. In this slide, we can easily understand the process behavior in an out of control state. Out of control means outliers, defects. The elimination of assignable causes bring the process to the stage of control. The second graph implies that the process behavior is an in control state. In any production process, our main aim is to control and maintain the quality of the manufactured product during production so that it comfort to the specified quality standards. The methods used for this are called process control techniques and is generally achieved through the technique of control charts developed by W. Shiva. By product control, we mean controlling the quality of the product after its production by critical examinations at strategic points, and this is mainly achieved by using sampling inspection plans proposed by Dodge and Roming. The product control aims at guaranteeing a certain quality level to the consumer regardless of what quality level is maintained by the producer. In short, process control techniques aims to ensure that all the produced items are conforming to the specified quality standards, and product control techniques attempts to ensure that the products marketed doesn't contain the large number of unsatisfactory items. So this method is the process control techniques. Basic principles of statistical quality control. In a production process, we are trying constantly to make products that meet the consumer's requirements. We are also trying to make each items or products as much like as the others as possible. For this, we must keep control of our operations. Just like a doctor uses temperature, pulse rate, blood pressure, reading sugar level, cholesterol level, etc., to keep track of the patient's conditions. We use control charts to monitor the conditions of our production process. When properly used, control charts will tell us three things: when we are doing something we should not, when we are not doing something we should, when we are doing things right. Generally, control charts will indicate how well our job is. They will provide us with stop and go signals. These are the basic principles of statistical quality control. The ideas and techniques of statistical process control are based on the following six principles. The first one, no two things are exactly alike. That is, the variability is inherent in all production process. The second one, variations in the product or process can be measured. The third one, things vary according to a definite pattern. The fourth one, whenever things of the same kind are measured, the large group of measurement cluster around the middle normal curve assumptions. The fifth one, it is possible to determine the shape of the distribution curve for products manufactured by any process. The last thing, variations due to assignable cost tends to distort the normal distribution curve. Statistical methods give us a way to picturize and control quality through use of histograms and various control charts. The X bar and R chart, S bar and S chart, then P chart, C chart, U chart. There's so many types of process control charts are there. These 6 points are under the principles of statistical process control. Histogram. Many families, it is customary to have a picture take each year. Just a family photo, the histogram is a snapshot or still photo of a group of products for the manufacturing process. It shows how a process is operating at a given time. Engineering specification. Three questions can be answered by the quick look at the pattern of the histogram. Is the process producing items according to the bell-shaped curve? That means a symmetrical curve. It is normally distributed. Where is the process centered? Aim at value. Is the process is capable of meeting the engineering specification? That means the process capability. Since the histogram is merely as a snapshot of the process, if we collect another set of observations from the process at another time, the picture may be different. So histogram is not suitable for continuously monitoring the process. To monitor the performance of the productions process continuously, we have another useful tool, the control charts. Okay, thank you for watching.